What's up, friends? In this video, we'll be discussing objective Verma, objective questions from H.C. Verma, and this is the first chapter. Let's start with the first question. Which of the following set cannot enter into the list of fundamental physical quantities in the system of units? Basically, क्या है कि if fundamental physical quantities की एक property है that they should not be derived from other fundamental physical quantities. Okay, one cannot be expressed in terms of other fundamental physical quantities. So length, mass, velocity हो सकता है, but mass, time and velocity नहीं हो सकता, because mass, time, velocity को अगर देखें तो ये define हो जा रहे हैं. Length, time, velocity can be derived from L and T. So L, T and V simultaneously cannot be a part of this fundamental physical quantities in the system of units. Next question is, आपको बताना है physical quantities measured और NU express की जा रही है, where U is the unit, N is the numerical value. Result is expressed in various units. तो बताना है आपको कि क्या होगा. Obviously अगर आप यूनिट छोटी लेंगे तो न्यूमेरिकल वैल्यू आपकी बढ़ जाएगी. फॉर एग्जांपल जैसे कि हम किलोमीटर्स की बात करें तो 1 किलोमीटर इज 1000 मीटर. मीटर इज अ स्मॉलर यूनिट, तो आई हैव डिक्रीज द यूनिट, numerical value has increased. Similarly, this is also equal to 10 to the power 5 centimeter. Again, I have decreased the unit, numerical value has increased. Okay. In the next question, there is a quantity x which is represented in terms of m, l, t with their powers as a, b, c. We have to find which of the following statement is correct. Okay, so the quantity m can be defined in terms of x, l and t only and only when a is not equal to 0. Okay, then only x will depend on m and m will depend, or m can be expressed in terms of x. Okay, listen very carefully. If x is m to the power 0 and l and t can have any values of power, so x is not dependent on m. So m cannot be expressed in terms of x, l and t if its power or a is 0. So it can be defined only when its power is not 0. So it may be represented in terms of L, T and X if A is not equal to 0. So D is the correct answer. Fourth पर आते हैं, a dimensionless quantity. Obviously a dimensionless quantities can have unit or it may exist. So it may or may not have a unit. Like theta. Theta is a angle. Angle is a dimensionless quantity, but it has a unit radian. Similarly, another dimensionless quantity, which is strain, has no units and also have no dimensions. A unitless quantity never has a non-zero dimension. A unitless quantity cannot have dimensions because it has no unit. If it will have dimension, then it must have units. Okay. So we can say a unitless quantity must be dimensionless. It must be dimensionless. So it always never has a non-zero dimension. So we'll go with A. A unitless quantity can never have non-zero dimensions. Moving on to the next, which is this: as 2x minus x square is defined. So 2ax is subtracted from x square. So dimension of ax should match x square. So dimension of a should be same as x. Okay. So we get x in the numerator and x in the denominator as well. So this whole quantity is a dimensionless quantity. Okay. So listen very carefully. The whole quantity is a dimensionless quantity, and this a has dimension of a is dimension of x. So we can say that dimension, as the left hand side is dimensionless, right hand side should also be dimensionless. Sine inverse is always a dimensionless quantity, and this should also be dimensionless, so the power of a should be 0. Okay, so we can go to the solution. We said dimension of a is x, which is because 2ax minus x square is given, and dimension of dx, which is the dimension of x, dx is nothing but small value of x, so it will have same dimension of x divided by the dimension of x, so it is a dimensionless quantity. So a to the power n should match with L to the power 0, so n must be 0. Now we will discuss objective 2 from the same chapter. Let's start with the first question. The dimension of m L minus 1 t to the power minus 2 may corresponds to. Okay, so this value m L minus 1 t minus 2 can be expressed as this. M is mass, LT minus 2 is acceleration. Because it is minus 1, so we have to divide by L square, so area. So we get m L minus 1 t minus 2 as mass into acceleration upon area. Okay, so what I did, I just multiplied and divided by length, so we get mass into acceleration as force upon area is pressure, and mass into acceleration is force into some length will be energy, and this area into length will be volume, so it can be also expressed as energy per unit volume. So this dimensions of this will match with pressure and energy per unit volume, because work done is ml t minus mlt ml2 t minus 2, and linear momentum will be this kg meter per second, so it will be ml t minus 1. So upper two will not match, whereas C and D options are matching. Moving on to the next, choose the correct statement. A dimensionless correct equation may be correct. Okay, so what does dimension analysis give you? We can prove that the statement or the equation is incorrect if it is dimensionally incorrect. Okay, so we can say dimensionally incorrect equations must be incorrect, but the converse is not true. That means if an equation is dimensionally correct, it may or may not be correct. Okay, there may be some constant which are left, there may be some dimensionless quantities which are left. So if it is dimensionally correct, we are not sure whether the equation is absolute or not, so we'll go with A, B and D, which says dimensionally correct equation may be correct. Yes, a dimensionally incorrect equation may be correct, C is wrong, and B and D are also correct. The last one is choose the correct statement. All physical quantities may be represented dimensionally in terms of base quantities. Obviously, all physical quantities can be expressed in terms of base quantities. A base quantity can never be represented dimensionally in terms of rest of base quantities. These are the properties of fundamental or base quantities. So B is also correct. The dimension of a base quantity in other base quantities is always 0. That is just a different way of saying the option B. So it is also correct. The dimension of a derived quantity is never 0 in any base quantity. No, the derived quantities can have any base quantities uh, has 0 powers. So let's say velocity is m0 lt minus 1. So velocity has m to the power 0, so the option D is incorrect. So we'll go with A, B and C. Okay, thank you.